So what we're going to do now is we're going to use the unit circle to evaluate the following trigonometric functions. The first one, what we want to do is we want to evaluate the sine of pi over 4. Okay, so our key thing is we want to go over to pi over 4, which we know is our 45 degrees. Okay. And remember from the previous slide that the sine function is the y coordinate over the radius. Okay. And in this case, since we're on the unit circle, our radius has a measure of 1. So now what we want to do is we want to see what the y coordinate that corresponds with our pi over 4. In this case, our pi over 4, the y coordinate is square root of 2 over 2. So let's write that down, square root of 2 over 2. So when we evaluate the square root of 2 over 2 over 1, we know that it's the square root of 2 over 2. So sine of pi over 4 is square root of 2 over 2. Let's go ahead and look at the cosine. So we need to find the cosine of negative 2 pi over 3. Okay, so what we want to do is we need to count to see where the 2 pi over 3 is since it's negative. Remember, if it's negative, we're going to be going clockwise. Okay, so negative 2 pi over 3. Okay, so if we go all the way over here, it's negative pi over 3, and if we go this way, it's going to be negative 2 pi over 3. Okay. So these are the coordinates that we're going to be using, the ones that correspond to the 4 pi over 3. Okay, so we want 1 pi over 3 and another pi over 3 onto that. Let's remember that our cosine is our x-coordinate over our radius. Once again, our radius is 1, and our x-coordinate is going to be negative 1/2. Okay, so we're going to simplify this, so it's negative 1/2. So the cosine of negative 2 pi over 3 is negative 1/2. Let's look at the tangent of 6 pi. 6 pi is, if we go around the unit circle 3 times. Because if we go around the unit circle once, it's going to be 2 pi. Go around another time, it's going to be 4 pi. Go around a third time, it's going to be 6 pi. Okay. So the coordinates we're going to be using that correspond with 6 pi is 1, 0. The tangent of 6 pi, we know the tangent is defined to be the y-coordinate over the x-coordinate. In this case, our y-coordinate is 0, and our x-coordinate is 1. So 0 divided by 1 is 0. So the tangent of 6 pi is 0. Okay, so let's go ahead, and what we want to do is we want to look at the cosecant of 7 pi over 4. From our previous slide, we know that the cosecant is the reciprocal of the sine. So in this case, it's going to be the radius or the hypotenuse of the triangle over y. Okay, so let's go ahead. We want to find 7 pi over 4. So we have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and then 7 pi over 4 right here. So the coordinates we're going to be using are square root of 2 over 2, comma negative square root of 2 over 2. Once again, we know that our radius is 1, because it's the unit circle. The hypotenuse of our triangle is 1. And the y-coordinate is going to be negative square root of 2 over 2. However, when we look at this, it's not a pretty fraction. So what we want to do is we want to make it pretty, so to say. Since we're dividing by a fraction, what we're going to do is we need to multiply by the reciprocal of our fraction down here. So we have 1 times 2 over negative square root of 2. Okay, so that's just 2 over negative square root of 2. However, we don't want to have a square root in the denominator, so what we need to do is we need to multiply both the top and bottom by the square root of 2. So times square root of 2 over square root of 2. So the top becomes 2 square root of 2. And remember, there's that negative sign that we're carrying over 2. Because this becomes the square root of 4, reduce it becomes 2. We can reduce, we have 2 in the numerator and the denominator, so those are going to go away. So you have negative square root of 2. So the cosecant of 7 pi over 4 is going to be negative square root of 2. Let's go ahead and look at the secant of 5 pi over 6. The first thing that we want to do is to find where 5 pi over 6 lies on the unit circle. And we see that 5 pi over 6 is right here, or 150 degrees. The secant, once again, is the reciprocal of the cosine. So our secant is going to be the radius over x. So we know that once again our radius is 1. And the x-coordinate is negative square root of 3 over 2. So what we want to do is kind of the same thing that we did for the cosecant. Once again, since we are dividing by a fraction, we need to multiply by the reciprocal. So 1 times 2 over, let's make that negative, square root of 3. Okay, so it's just negative 2 over square root of 3. And what we want to do, once again, is we need to rationalize that denominator, so multiply the top and bottom by the square root of 3. So we have negative 2 square root of 3 over 3. And in this case, we can't simplify anything, so the secant of 5 pi over 6 is going to be negative 2 square root of 3 over 3. The last one that we want to look at is the cotangent of 5 pi over 3. Once again, our cotangent is the reciprocal identity of the tangent, so it's going to be x over y. So we need to find where 5 pi over 3 is, and it is right here. So we're going to be using these coordinates for it. So the x-coordinate is 1/2, and the y-coordinate is negative square root of 3 over 2. So once again, we're dividing by a fraction, so that means we're going to be multiplying by the reciprocal of the 1 in the denominator. So 1/2 times negative 2 over square root of 3. What we see here is our 2's will cancel. So we have negative 1 over the square root of 3. Once again, we need to rationalize, so multiply the numerator and denominator by the square root of 3. So we have negative square root of 3 over 3. We can't simplify anymore, so we find that the cotangent of 5 pi over 3 is negative square root of 3 over 3.